to do it. So yes, let me mention this first off. The practice exam 4 on the other class. What is it? Math. The other class YouTube. The other class YouTube. Math 4b-tr. Tuesday, Thursday, my Tuesday, Thursday class. I meet with them for 2 hours every time. So I made it through there. So practice exam 4 on the other classes YouTube. Math 4b/tr, practice exam 4. That one, the whole thing is there. So I'm only going to get through part of the problems in these 50 minutes, I'm sure. I won't get through the whole thing. But I made it well, except for the last 2. I didn't get the last 2 done. Other than that, I did everything on the other one.
Could you do the last 2 for us, and then that way we could have everything else?
I guess I could. Maybe I'll do them quick. They're fresh in your mind. They're binomial. But, yeah. So there he is. So I want this on the YouTube and let you know. You go to the Math 4B Tuesday, Thursday. The whole thing is there for practice exam 4. All right. All right. So here we go. 25. The coefficient of x to the 8th in the expansion of that. So remember the whole binomial theorem thing? You take the first term, x squared. You take the second term, -3. Binomial, 2 things, right? You just list them side by side, and then you just go down the way. Remember this? And you just do the pattern. I think maybe one more. I don't know how many. Okay, then remember, what's the pattern on the powers? How do we do it? We start with whatever power they gave us there, right? 7. So start with 7, 6, 5, 4, 3, 2, 1, 0. Remember that? And then for the second of the binomial of the 2, you start with 0. 1, 2, 3, 4, 5, 6, 7. Right? And then what do you put in the front? The parentheses, the 7. Again, start with the power 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. Now, they're not asking me for all of those. They're only asking me for the x to the 8th term. Which one's the x to the 8th term? Do you see it? Which one, if you multiply these out, would come out with x to an 8 power? That one. 2 times 4. There's your x to the 8th, huh? So that's the only one they want. They just want 7 choose 3, x squared to the 4th, minus 3 to the 3rd. That's the only one they want. Just work that one out. Is that good? So what do you got? 7 choose 3. Remember how to do the choose? You use your calculator?
Yeah.
Just do 7c, not 2, 3 on your calculator. Is it 35? Yeah, 35 times x to the 8th times minus 27. So multiply 35 times minus 27 on your calculator. You get minus 945. A. Good? Remember all that? Binomial stuff? So there we go. All right, I'm going to be flying today. So let's go on to number 26. So this will be all on the YouTube later.
Question.
Yeah.
Why is it that being circled again? I forgot.
Because they wanted x to the 8th.
X to the 8th.
And this one, 2 times 4 would be the 8th. So I'm just grabbing the one that makes x to the 8th on that. They only wanted one of the terms on that. So I just grabbed that one. And make sure you can do this on your calculator. Get 35, and 35 times minus 27 is negative 945. X to the 8th. But they just want the coefficient. They just want the number. Is what they said on that. Good? So binomial, so it's the same thing. Remember how it works. You start with the first one, the 4x, then the second one, the 2. The 4x, the 2. The 4x, the 2. The 4x, the 2. The 4x, the 2. What's the powers they want me to put on here? Fifth. So start with 5, 4, 3, 2, 1. I guess I got to do one more. 0. And then vice versa. 0, 1, 2, 3, 4, 5. And then I put the parenthesis thing in the front. Start with the power again. 5. 5, choose 0. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. 5, choose 5. Good like that. And then just work all those out. So this one, 5, choose 0 is going to be 1. 4, yeah. Yeah, can I just leave it at that? So this, here, I'll just put the code. This is 1. This is 5. This is 10. 10 again. 5, 1 for those coefficients. And then you just do the 4 to the power and 2 to the power. Get all the terms. Find the right answer. Good on that. Remember all those patterns for the binomial theorem. All right, I'm going to go back to number 1 now. So back to number 1. All the formulas are at the top. And let me tell you what they are to help. These two are arithmetic formulas. These 3 are geometric. So the ones that were easier, arithmetic, when you add or subtract, arithmetic, adding, subtracting from term to term. Geometrics, when you multiply or divide from term to term. Those 2 in the middle, I don't think we ever really used those, did we? I think I must have done something different some other semesters. We don't use that. We didn't really use those. All right, anyway, here we go. So number 1. So part 1 is no calculator at all again, right? No calculator at all on part 1. Okay. Cosine of 8 pi over 3. So how can we do that without a calculator? Unit circle is going to be on your 3x5 card, right? So let's do that. 8 pi over 3. Let's go to the unit circle.
Cosine of that would be 1.
Where did the unit circle go? There it is. Okay, there's the unit circle. I don't see 8 pi over 3. Yeah. There's 2 ways you can do it. You can say, look, I'm going to subtract a full circle, 2 pi, because that's beyond the full circle. Yeah. Subtract a full circle, that's 2 pi over 1. Multiply top and bottom by 3, and you'll get 8 pi over 3 minus 6 pi over 3, which is 2 pi over 3. So you really want to find the cosine of 2 pi over 3. That makes sense what I'm doing. I subtracted a full circle. Or, I know this bugs some people. They'd rather work in degrees, and that's totally fine. I'll say, or you could just take your 8 pi over 3 and change it to degrees. So how do you change degrees? What is pi changed to degrees? 180. Remember that? Pi is 180. So just put in a 180 there. This is the other way to go. I'll say or. So, and then if you work that out, you'll get 480. 480 is more than a full circle.
We just add the extra.
So just subtract 360, you get 120. So 120 or 2 pi over 3, they're the same spot. You'll see on the unit circle, they are one. They are one location, just set in radians or set in degrees. Same amount of angle opening. So let's go find it. 2 pi over 3, 120, same thing. Here it is, 120, 2 pi over 3. See, they're the same spot. They're this spot right here. Remember, the x is cosine, the y is sine. So what do they want? Cosine, right? Negative a half. Watch that. Negative sign's tiny. It's the only thing I don't like about this unit circle I got off the internet. Otherwise, it's perfect. They made the negatives too small. Negative a half. So the answer is negative a half. So whether you do it by radians or by degrees, whatever you prefer, A is the answer. Negative a half. So no need for a calculator. Just use the unit circle. So you want to put this, for sure, this is like the most important thing on your 3x5 card. I'd make one whole side of my 3x5 card be this unit circle. Would be a good idea. Put that right there as the one side of your 3x5 card. All right, so let's go to number 2. Questions on that? We good? Number 2. Okay, so cotan of 570. So again, subtract 360. That's more than a full circle. What was it, 210 degrees? Yeah. So we want cotan 210. How do you do cotan? What's the definition of cotan?
That's the x over y.
Yeah, cosine, x over y, cosine over sine. Yeah, remember that? Tangent, if they'd asked me tangent, is sine over cosine, right? And cotan's upside down to that. So let's go find cosine of 210 and sine of 210. So where are we at? 210. Get rid of this. 210 is here. So cosine, sine. So cosine's minus root 3 over 2. Sine is minus a half. So minus root 3 over 2. Minus a half. Got it off the unit circle. Right? You all see that? Right here in the unit circle. 210. So then grab this, flip it up. So we get minus root 3 over 2 times minus 2 over 1. 2 minuses make plus. The 2's cancel. It's plus root 3. Oh, they don't.
None the above.
It's
Or
no-
D. No, none the above.
It's B.
Oh, B. Yeah. I don't know why it looked funny.
Oh,
huh?
it looks so funny.
It does to me too. I don't know what that was weird.
Oh,
B.
yeah.
Is that a,
It's like a mirage or something. I
is
don't
that
know.
a dividing sign or?
This? It's plus.
Oh, okay.
I'm just emphasizing. You don't
For
need
a
it.
second there, I thought
I'm
it
just
was-
emphasizing that it's no longer negative. 2 negatives make positive. Good there? On that? That whole thing? I'll move on. Use the unit circle, right? So cosine, pi over 3, tangent, 5 pi over 3. All right, let's go to the unit circle. Pi over 3, cosine of pi, erase the old one. Go to cosine of pi over 3. Where's pi over 3? Here. So cosine sine. So cosine's a half. So that's a half. Plus. Now tangent of 5 pi over 3. You know tangent. Sine over cosine. So what's the sine of 5 pi over 3? Where's 5 pi over 3? Where are you? There he is. 5 pi over 3. Cosine sine. So cosine's a half. Sine's negative 3 over 2. Cosine's a half on the bottom. Negative 3 over 2 on the top. Good to there?
Isn't that just the same thing as the other one? No. This one would just come out negative, right?
I think so. Flip it up. So we get a half plus negative root 3 over 2 times 2 over 1. Boom. So that's a half minus root 3. Now, you really have to do one more step because look what they did. In all the answers, they put them together. They made one fraction out of them. So I can't leave them two separate things. I've got to put them together to see if my answer's there or not. Don't be too quick to grab none of the above. So let's put them together. How do you put them together? How do you combine them into one fraction? Over 1, get a common denominator, top and bottom by 2. So 1 minus 2 root 3 over the common denominator of 2. Now that's not there, so we will grab none of the above. That good? That bug you? This 2 went to the front, and 2 times 1 made 2. Both denominators are 2, right? There we go. So it's none of the above, which is always a little disturbing. All right, so number 4. Tangent of theta is minus 15/8. Theta is between 270 and 360. Remember these kind? Got to draw the triangle, put it in the right quadrant, that whole thing. Which quadrant we in?
270 to 360 to the bottom right.
Fourth quadrant, bottom right. 270, 360. What do you got to remember when you draw your triangle with your theta angle?
Always against the x, right?
Always against the x-axis. Yeah, remember, because that makes it a reference angle. That means whatever values are the same as if you put that angle in the first quadrant. Because in the first quadrant, they're always off the x-axis, and that's where you start with 0 degrees. So remember, always, whenever you're in any quadrant, put your angle against the x-axis. In other words, don't put it here. Don't make a triangle like this. This would totally mess you up. I see this. Don't do that. That would be wrong. Don't make your angle against the y-axis. Reference angles go to the x because that's where 0 starts in the first quadrant, is on the x-axis. This is 0. All right, so put theta there. Right angle, okay. Now, they're giving me tangent. Remember SOHCAHTOA? SOHCAHTOA. Tangent is opposite over adjacent. So that means this is opposite, this is adjacent for the tangent right there. Now, from theta's perspective, this side's the hypotenuse. This side's adjacent because it's touching theta. This side's the opposite because it's across from theta, right? So tangent is opposite, 15 is opposite, over adjacent is 8. So now I've got to find the hypotenuse with the Pythagorean theorem. Okay, so 8 squared plus 15 squared is c squared. Remember, a squared plus b squared is c squared? This is c because it's the hypotenuse. It's the side across from the right angle, the longest side. Remember all that? Question, Barbara?
Would it be negative 15?
Oh, yeah, but it doesn't matter, huh? Because negative 15 squared would still be 15. But you're right. I'm being kind of casual. Yeah, you're right. It is technically negative 15. And you can be real careful with all that, and you'll be right. Or I'm just going to fix the signs at the end with all students take calculus. Okay. Either way. I'm gonna not worry about signs and handle it at the end. But you're right, it is technically negative 15. Square that, it's 64. This is 225, c squared. 289, c squared, root of 289. You all know off the top of your head, this is the no calculator part. 17. Do y'all know that?
So I gotta know that?
Yeah, maybe I'll double check the exam to make sure there's not numbers quite this big. All right. 17 is the hypotenuse. Square root of 289, 17. All right, now we can answer the question with the greatest of ease. They want cosine. What's cosine? Adjacent over hypotenuse. Cosine is adjacent over hypotenuse. What's the adjacent? 8. Hypotenuse 17. 8 over 17. Now, we have to decide, is it positive or is it negative? All students take calculus.
Negative. Wait. No, negative.
All students take calculus.
Oh,
Isn't
yeah,
it in the
yeah,
fourth
yeah.
quadrant?
X.
All students take calculus. So you're in the fourth quadrant. In the fourth quadrant, only cosine is positive. So he's positive. 817. So there it is. Good?
I need to start fresh.
Oh wait, so each letter represents the thingy, and then it's positive for those only in that quadrant, right?
Right. So cosine. Oh, right. It's only. That's right. Yeah. Cosine and his upside down secant. Yeah. So cosine and his upside down, his reciprocal secant, are only positive. They're the only. The other four are all negative. Yeah. That's what the quadrants mean. They're all positive in the first, all 6 trig functions. But in the other 3 quadrants, just sine and his upside down cosecant, just tangent and his upside down cotan. The other 4 are negative. Correct.
I never knew.
It's just the ones that are positive.
I thought you just put letters there, and you guys are just.
Doing whatever, huh? Yeah. No, those are the positive ones. Yes. Good question. Good clarification. Good. All right. So let's try number 5. Cosine theta is 2/5. Tangent theta less than 0. All right. Find the quadrant you're in. They're giving you enough information using the all students take calculus to figure out which quadrant you're in.
1. Cosines. X is 2. It looks like it's in the first one.
Yeah.
All students take calculus. Cosine is positive, 2/5, so it's positive. Tangent is negative. So somebody's negative, so we're not in the first.
Yeah, we're not in the second either, right?
And who's positive?
Cosine.
Cosine. So we're in the fourth,
Bang.
Okay.
right? Because cosine's positive and the other 4 are negative, like tangent. Why can't we be here? Well, tangent would be positive in the third, and they're telling us tangent's negative. Why can't we be here? Sine would be positive, but the other would be negative, which means cosine would be negative. And cosine's not negative.
Will be 2 squared.
We're in the fourth. Good? Cosine's positive, and tangent is negative. Fourth quadrant. All right. So we're in the fourth quadrant. Put your angle theta to the x-axis.
What equals
All right.
4? Yeah.
Cosine is 2 over 5. Cosine, now remember the SOHCAHTOA.
Plus or minus 4.
SOHCAHTOA. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. Cosine is, so this is theta, this is the hypotenuse. This is the adjacent side, this is the opposite side. So cosine is adjacent over hypotenuse, it's 2 over 5, like that. Can we find the opposite side? So we use Pythagorean. So 2 squared, we'll just call this b, plus b squared is 5 squared. 2 squared plus b squared is 5 squared. And so we get 4 plus b squared is 25. Subtract 4, b squared is 21. Root it. B is the root of 21. That's the opposite, root of 21. Okay, now what do they want from me? They want sine. That's opposite. SOHCAHTOA, that's opposite over hypotenuse. Opposite, root 21 over hypotenuse 5. Root 21 over 5, root 21 over 5. Wait a minute, I don't see root 21 over 5. I just see negative. So I should do none of the above.
No,
because it's
sine is.
anything.
Yeah. Double, I'm doing all that just to emphasize, double check your signs at the end, right? All students take calculus. So who's positive?
Cosine.
This tells us which ones are positive, right? Cosine is positive, and his upside down secant, but everybody else is negative, which means sine is negative here. Negative, so it is A. It's not E. We good on that? Cyrus.
How can you tell which side is the adjacent and opposite?
Yeah, so from theta's perspective, first off, this is the hypotenuse because that's the one across from the right angle.
Okay.
So we know that. Now, adjacent means next to you, right? So like Barbara's next to me, right? Opposite, you're more opposite. You're more far away from me. So adjacent, so this side is right, these two sides are right next to theta, aren't they?
Oh, we're talking about in terms of the theta.
From where theta is, right. You got to stand where theta is and say from theta's perspective, who's next to him? That side. So that's the adjacent. This side is opposite him. Yeah, it's from his perspective. Yeah, Luis.
Adjacent means that they share an angle. Two sides share an angle.
Yeah, right. Yeah,
Always will share an angle.
right. Exactly. Yep.
Always an angle in common.
All right, number 6, cotan. What's cotan? That's always cosine over sine, so this is a cake one. So root 15 over 4 over 1/4. Grab it, flip it. Root 15 over 4 times 4. 1. Cancel the 4s. Root 15. We're done. Easy problem. D. Good? They're just making sure you know the definition of cotanent. This test has a lot of some difficult stuff. So, all right, so number 7. Y equals x squared minus 13. X squared plus y squared is 25. This is a pretty challenging problem. Okay, notice in the answers, they want y, don't they? That's all they want. They only want x. They just are asking for y. There's an easy way and a hard way to do this problem. If you want to see the hard way, look at my the other class's YouTube. Last hour, I did it the hard way. And then a gal said, hey, Mr. and I did it this other way, and it was way easier, and I did it her way, and she was totally right. It was way easier. So I'm just going to do it the easier way this time. So you could take that y, and you could plug it in, right? Because y is this. You could plug that right in there for y. But that's hard. It gets messy. It's a lot of work. What's actually a lot easier is to solve for x squared. Yeah, it turns out. So let's do that. So I'm going to take this first equation. I'm going to get x squared alone in the first equation and plug it in for x squared in the second equation. So I'm going to grab that minus 13 and move it over there. So that'll be y plus 13 is x squared. Good so far. And then I'll take that and put it in right there. So we'll get y plus 13. And now we can just solve that. Does that make sense what I did? I replaced x squared with y plus 13 because x squared is y plus 13. First equation told me x squared is y plus 13. So I stuck that in to the second equation. Get to there. and then subtract 25 from both sides.
Get a 0.
So factor this thing. And what two numbers multiply to be 12, add to be 1? What times what is 12? 4 times 3. Remember how factoring works? Sign in the middle goes on the bigger. Plus 4 minus 3, like that. So the answers are minus 4 plus 3. There we go, minus 4 plus 3. Boom. We got it. Yeah.
For that answer sheet, it was actually C, so was it just
Oh, was it?
7? Yeah.
7 was C?
Yeah.
Yeah, one of them. It wasn't.
It was C.
7 was C? Let me do. Yeah, so it looks like the answer key's wrong on this. The real answer is B, minus 4 and plus 3.
19 has that issue too.
Yes.
Yeah, that's the other one I wrote down. It's the answer's E actually on 19, huh? Yeah. Did you get 1.03 on 19? That's what I got when I did in class. Yeah, I'll get to that one eventually. All right, we'll move on to number 8. Oops, that's not what I want. Come on. There it is. Okay, number 8 is going to be a little challenging. So number 8 is a 3 by 3. 3 letters, 3 equations, and there's no calculator. So we got to solve this. A lot of doing these well is forming a good game plan. Let me help you with that. As you look at those 3 equations, basically we need to, remember what you do with 3 equations, 3 letters. You eliminate. You get one of the letters to drop out. Doesn't matter which one, just get rid of X or Y or Z, but get somebody to go away. First off, notice the answers, they want X. They only want X. I'm trying to save you some time, so you don't have to find all 3 letters, just find X. So if you want to find X, then you really want X to stay around, to hang around. You don't want to eliminate X. So, okay. So how about I eliminate Y? Could I eliminate Y? Yeah, Y is begging to be eliminated. Look at it. Plus Y here and minus Y there and plus Y here. See how the one in the middle is negative and it can knock out the top one and the bottom one? So I'm going to use the second equation like a hammer to hammer Y out of the first equation and out of the third equation. The second is my tool. I'll add it to the first, I'll add it to the third, and Y will drop out of both. Then I'll have 2 equations with X and Z, and that I can handle, right? 2 equations, 2 letters I can do. All right, so here we go. So equation 1 with equation 2. Everybody see that? And see when you add them, what happens? Bye-bye Y's, right? So 1x is 2x. 1z, 4z, 5z. This is negative 3. I knocked Y out. And then I need to do the same thing again. Now take equation 2. Again, 2. 2's my hammer because he has the negative Y in the middle. Everybody see and think that the reason I know to use him? And then add equations 2 and 3. Again, the Y's drop out, huh? See why I keep using equation 2? Just somehow get a letter to drop out. I'm dropping Y out of all the equations. 1x and 2x is 3x. 4z and 1z is 5z. It's negative 7. So now I have this and this, 2 equations that just have 2 letters. That I can handle. So let's do it. So 2x plus 5z is minus 3. 3x plus 5z is minus 7. All right, so what should I do to finish solving those 2 equations with 2 letters? No more y's. What do I do to get rid of? I want to get rid of somebody else.
Z.
Yeah, get rid of z. 5z, 5z. Just make one of them negative, huh? That makes sense? Doesn't matter which one. I'll just maybe do negative 1, negative 1, negative 1 through that top one. So you have minus 2x, minus 5z, plus 3, and then just bring down the second one, no change. And then add them up, and the 5z's drop out, huh? 3x minus 2x is 1x equals negative 4x is negative 4. And it's not there. Disturbing. None of the above. Good? On we go. So I got y to drop out of all the equations. So part 2, theater has 20 rows, 28 seats in the first row, 33 in the second. Okay, so it's saying, so the first row has 20. No, not 20, 28. First row has 28. The second row has 33. The third row has 38, and so on, all the way down to the what? 20th row, right? Because they said there's 20 rows, and I don't know how many in the 20th row. And they want me to know what they all add up to be, what the sum of them equals, right? Because they want me to add up total seats in the theater. So, what am I going to do? Is that an arithmetic? First off, am I talking an A sub n formula or S sub n?
S sub n, right?
Now, sum, that's going to be an S sub n, isn't it? So it's either this S sub n or it's that S sub n. There's two. This is the arithmetic. These will be right on the top of the test. You don't even need to put them on your 3x5. You have room to put the whole unit circle on one side of your 3x5. I'm giving you these right at the top of the test. So how do you know? Is it arithmetic or geometric? What's it doing from term to term?
It's jumping, adding by 5.
It's adding by 5. Adding, subtracting is what you first did in math when you were a young'un, right? Arithmetic. Arithmetic is adding, subtracting. So it's an arithmetic. So I use the arithmetic one. If it was multiplying or dividing from term to term, that'd be geometric, right? That's higher up. So arithmetic is adding, subtracting. So grab the S sub n, the arithmetic S sub n. There's my formula. Just grab it right here and use it. So now, what do the different parts mean, though? This is what you really probably want to put on your 3x5. N means number of terms, or maybe you know it already. Number of terms, A1 is the first term, AN is the last term, huh? All right, so let's give it a try. Do I know the number of terms? Do I know N? 20 terms, right? Aren't there 20 numbers here?
Mm-hmm.
What's A sub 1, the first term?
28.
28. Plus, what's A sub n, the last term?
We need to put it in the other formula.
Yeah, I don't know. It's right here. And I have a formula for A sub n right here. I got to find it. A1 plus n minus 1d, huh? To find that last term, that nth term. All right, so it is A1, which is already 28. Plus n, number of terms, 20 minus 1. D, what's the D? That's the 5. That's the difference, the jump from term to term. So 28 plus 19 times 5. Yeah, so 28 plus 95, 123. Bring that back. 123 is the last term. This is 123. The last term, put it in there and work it out from there. What do you get? 20 over 2 is 10 times some big number, 151 is 1510. 1510 C. 1,510 seats. Figure out how many seats in a pyramid kind of setup that way. Questions on that?
So n is the number of terms. What is an? What's the?
A sub n is the last term. It's the arithmetic at the nth spot. The arithmetic term at the nth spot. N being the last spot, because n's the number of spots.
Didn't you say it was something like cardinal number or something like that?
Oh yeah, that's right. Yeah, that's another way. Yeah, whenever you go 20th, that's always n.
So an, the an
Is a sub 20, really.
is the 20.
It's the 20th term, which is the last term, which is 123. Yeah, right. Cardinal number, ordinal, cardinal, whatever you want to call it. The TH thing, that's n. Good, Luis. Good memory. We'll use that more strongly in a second. We'll be the very next problem, I think. Okay, 42nd. Yeah, as soon as you see that, you know that's in, huh? Any of those order, anything that implies an order, right? 40. If I just say, hey, how many people were there? 42. That's not an order. But I say, what place did he come in? 42nd place. That's an order, right? In is always, that's always in.
In terms of notation, it would be a sub 42.
Yeah, wherever you find n. There's lots of places. One of them is as a subscript, and that'd be true. Yeah, so is this one now? So we're talking arithmetic, so I'm going to use one of the two arithmetic formulas. Is it S sub n? Are we adding them?
No.
No, there's no plus signs. It's not S sub n, no plus signs. There's commas instead of plus signs. So it's just A sub n for arithmetic. If you look back for the A sub n for arithmetic, it's right there. It's that one. Look back here. That one, arithmetic, A sub n. So we just use that one. Yeah, and then n is 42, like Luis is saying. So put in 42 everywhere you see n, as a subscript or anywhere. A1 is the first term, right? This means first. First term is -5. N, 42 again, -1. D, what's the difference from term? What's happening from term to term? -4, -4. Right? D is -4. Remember that D is multiplied at the back. Don't subtract 4. It's times D, right? So times -4 in the formula. It's timesed, even though it's subtracting in the sequence, right? So, okay, what do we get? -5 plus 41 times -4. -5 minus 164, which is -169. Is it not there?
Nope.
Oh, boy. There's a lot of E's, aren't there? Good there? So, movie theater, $8 for adults, $5 for children. All right, this is a money problem. In a money problem, the first equation is no money. The second equation is all about money. We didn't do a lot of these. We did like one in the lecture, one in the homework, I think. So, yeah, you know what? Right here's where I'm going to give you, I put 26 questions on the practice exam. There'll be 25 on the real exam. One of these two will not be here. You won't have both a money one and a mixture one.
Mixture.
I don't remember, to tell you the truth.
Take out the mixture one, Mr. Harris. No, you can go ahead.
All right, so adults plus children is 40. That equation has no money anywhere. That's just number of adults, number of kids, 40 total. And then you bring the money in. 8 times adults, $8 per adult, $5 per child, total money, $272. So that one has all the money in it, right? Money, money, money in that one. That's how you do money equations. Now, to finish solving this, what you got to do is make the fronts, or any part you want, opposites. I'll just do the front. I'll just multiply the top equation by -8. You can multiply through by -5 and get the c's to cancel. Be fine. Either way, just get somebody to cancel. So -8a, -8c, -320. The bottom equation. Add them up. A's cancel. -3c is -48. Like that. And then the last step, divide by -3. C is 16. Oh, but they want A.
Then we just subtract that from 40.
Yeah, there's 40 total people. So take 40 minus 16, 24 adults. There it is, B. 24 adults. Good on that, because there were 40 total. 40 people all together. So when I got 16 kids, I just subtracted from 40, 24 adults. Good? All right, let's see. All right, mixture. Mixture are done with the buckets or the beakers or whatever you want to call them. So you put the money at the bottom. Okay, so the money is $1.08 per pound. $3.05 per pound, $2.64 per pound. And then they're giving me one number on the top. They're saying 24 pounds of the $2.64 stuff. So that goes in the top, right? The amount, you always put the amounts in the top. So amounts in the top, dollars in the bottom. 24 pounds of the $2.64 stuff. What goes in the other? That's all the numbers they gave me. So what do I put in the other two blanks? X and Y. Okay, so when you have two letters, what do you need?
To cancel one out.
Two equations. First off, I don't have any equation. I just got a picture. I need two equations, and then I'll cancel. That's true. So how do you get your two equations? First equation is just the tops. You just go right across the top. X plus y is 24. The second equation comes from multiplying top and bottom. So top and bottom, 1.08x, top and bottom, 3.05y, top and bottom, 24 times 2.64. I'm getting, this comes out 63.36 over here. So see how I got those two equations out of the beakers or the buckets or whatever? Right, good. So we took the two beakers, we got three beakers, we got two equations, top, 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 and multiply, multiply, multiply. And now you know what to do, right? Get the fronts to cancel. So multiply through by minus 1.08, minus 1.08, minus 1.08. So I'm making the fronts opposites. And I don't even know what that is. 24 times minus 1.08, minus 2592. And then the bottom equation, add them up, x's cancel. Good to there. Last step, divide by 1.97, 1.97. So y equals, I'm getting basically 19. Y is 19. Now what are they asking for in the question?
More expensive candy should be.
How much of the more expensive? Which one's the more expensive, X or Y?
Y.
The Y is the $3 candy, the more expensive. So this is what they want. It's not there. Another, none of the above. Was that the answer on the thing? Was it none of the above? Yep, all right.
63.
63. I multiplied 24 and 2.64.
Oh.
We good there? Anything else I can answer on that one? All right, I'll move on.
Recursively.
So sequence is defined recursively. So A1 is 2, that means first term. AN is 3, A sub n minus 1 plus 4. Now the whole trick to this one is being able to read this second statement. What this says is any term, nth term, any term is 3 times the previous, add 4. That's what it's saying. Does that make sense? Any term is 3 times the previous, add 4. Did everybody see it? Because n minus 1 is 1 back from a sub n. A sub n minus 1 is 1 before a sub n, isn't it? Do you see what that formula is saying? Any term is 3 times the previous. N minus 1 is the previous term, plus 4. So that means if you have any term, like I have a 2, the next term, come over here, a sub 2, the next term is what? 3 times the previous, 3 times the previous, add 4. That'll come out 10. And then the next term, a sub 3, is what? 3 times the previous, so 3 times 10, add 4. Let me slow down. See how I'm doing that? See what I'm doing? I just keep taking 3 times the previous, add 4. So the first one's 2, 3 times the previous, 3 times 2, add 4, give 10. Then 3 times the previous, 3 times 10, add 4, 34. And then the next one, 3 times the previous, that'd be 3 times 34. Add 4 is something, 90, 102, add 4, 106. So there it is, C. Does that make sense? All about reading this statement as any term is 3 times the previous, add 4. Number 14.
Oh yeah, that goes into calculator.
Calculator, exactly. That's just hit the button. See, it says graphing utility. So remember how that works. Second matrix, go across, at least for the TI, go across twice, go to edit, and then enter the matrix 5, 3, 3, 2. Then quit out of that, and then do second matrix again, hit enter for matrix A, and then hit A and hit the x to the -1 button, which is the inverse button. Let's do that. Matrix. Quit that. Go back into matrix. Enter for A. Inverse. Boom. I'm getting.
5, yeah.
I got 2, -3, -3, 5 for my answer for the inverse C. You able to get that? If you have any trouble with the calculator on that, come on up and I'll be glad to help you. There's more that do the same thing, like 15, 16. There's a bunch more calculator ones. You definitely have to do matrices on your graphing calculator and know how to do that. There's one where you got to solve a 3x3 on your calculator. Remember, we have the inverse. You had to make 2 separate matrices, left side, right side, inverse, that whole thing. It's on the other YouTube. I did the whole thing. I wrote it out and solved it and everything. I'd be glad to help you. Office hours. So we're out of time.